resolution. Right?
So what
we didn't put a light through on the droplet, so we don't have to consider it problem.
So I believe that the deflected angle actually has a correlation with the magnification of the droplet. Therefore, if you consider a different light intensity, which provides a different wavelength, the speed that the light penetrates through the medium will be different. Therefore, the deflected angle will be affected. So I think this is a part of parameters that you can consider.
I think if you mean the graph will affect the result.
I'm trying to say that the speed that the light penetrates through the medium is determined by the wavelength, which is determined by the light intensity that you did mention in your theory, but didn't conduct an experiment. So I think this is a part that you can improve in your report. So next, I would like to talk about the thickness of the glass. Do you think the thickness of the glass will affect the magnification?
I think the thickness on graph might affect the light intensity, so it might have. I think in the optical magic, we can know the effect or it and draw a theoretical line to show the impact on the thickness of the graph.
So
here,
you ensure that the effect of the thickness of the glass. So you think that will affect the magnification. Then why don't you consider this in your experiment or your theory?
Because the more the drastic the light that it can go through will be smaller.
Yes, I acknowledge that.
And enough brighter that we can measure it.
So I not acknowledge that you think that this parameter is a relevant parameter. So I'm just asking that since you already know that it will affect, why didn't you conduct it in your experiment or your theory? So can I consider your theory is?
I didn't do this experiment, so I can use the formula explain about it. Actually, we just this.
So since your
our point is the optical properties of the water droplet length.
I mean, since your theory acknowledged the existence of the fact of this thickness of the glass, why didn't you conduct an experiment to prove it? Since that's the theory that you propose.
I don't think this.
So I think this lack of experiment to prove the theory also.
We use the experiment to prove that the curvature and the thickness of the water will affect the result. And in the glass, the thickness of the glass, I think is because we actually decrease the impact of the glass.
In the relevant parameters, the thickness of glass isn't a part of your experiment. It's a control parameters. Am I correct?
So, I don't think it is important for our this report because I didn't mention it in.
What is not important in the report?
Because our report didn't mention the thickness of the graph.
So you're a bit contradicting yourself, since
So
at the first place you mentioned that the thickness actually affects this magnification. However, then you mentioned that this thickness is not an important parameters in your theory. I think that's the part you may want to clarify, since to understand this phenomenon.
Okay.
Okay. So, do you think that if you place a droplet with the same shape can have different magnification in different positions?
I just say that we assume the droplet and the circle setting. So every part of the curvature radius is the same.
Can I use like this graph to explain what I'm trying to say?
Graph?
So if a line is actually in the center of the droplet, do you think it will be magnified?
In the line in the center of the droplet?
Center of the droplet.
You mean near your dot and it will
Yeah, if there's a dot in the middle of the droplet, do you think it will be magnified or not?
I think it will focus on the point.
You're going to answer the question. Will it be magnified or not?
I don't think it will magnify. And it will focus on the point.
So,
okay, sorry, time's up. So the opponent, please summarize the discussion. Opponent, you have 1 minute. summarize.
So in the discussion session, we discussed about the effects of light intensity. And I believe that the opponent didn't consider light intensity as a really important parameter. However, the light intensity correlates with the wavelengths of the light source. Therefore, it's a really important parameter in a droplet microscope. And also, we discussed how the temperature and humidity will affect the Young equation. I believe a more detailed theory should be provided in order to construct a model of shape for droplet that we can determine the curvature more easily. So, and also, we discussed the importance of the thickness of the glass, and I believe that the opponent at first acknowledged the importance of the thickness of the glass. However, later contradict to his own statement. So this is the vague part I discovered, and thank you.
Okay, thank you. So, reviewer, you have 3 minutes to ask question.
First, the reporter, do you think the gravity will affect the droplet, the shape of the droplet? Gravity.
We didn't consider in this. We just use the Young equation to solve the problem.
In this picture, you use a circle to describe the water, the shape of the water, right? But in real life, the curvature of the water is actually different.
So I assume it.
You assuming that is
And we do the experiment actually like this.
okay. So, what about? Do you think the magnification from the side and the middle are they all the same?
I think they won't be the same because we also need to consider the aberration in our experiment. So maybe I will do this in the future work.
So you didn't do the experiment of it.
But when we measure the magnification, we use this part, from the edge to the center and do a lot of calculation and averaging and get the data.
But you use the average curvature, right?
No,
No, you don't. You don't use the curvature in the middle.
no.
Oh, use all. Okay, okay. What about the opponent? What do you think the gravity will affect the shape?
I think in order to form an equilibrium shape of the droplet, it's actually requires the equilibrium between the gravity force and the surface tension force. So I do acknowledge the gravity force as relevant parameters during the shape of the droplet.
But gravity will actually will like make the droplet press and make the curvature actually smaller.
That's true.
Yeah, and you mentioned that the wavelength of light is a great parameter and in the resolution part. So what do you think the wavelength of light will affect the resolution?
So as the reporter mentioned in their radial criteria equation, you can see that the wavelength is actually part of the equation of measuring the resolution. So as the wavelengths gone bigger, the bigger the resolution.
Yeah. What about the reporter?
You mean
The wavelength of light at the wavelength of light will affect.
I think it will affect.
Then how?
The minimum angle that we can restore will be bigger.
Okay. And what about the bigger object? What does that mean? You mean the bigger object has a different magnification? If the object we observe use the bigger, the magnification will change. How will it change?
You said what I just.
Yeah, just opponent.
I'm actually trying to tell that if you observe a smaller object under the droplet's magnification will differ from position since the droplet's curvature isn't the same throughout the whole shape.
Yes.
Okay, time's up. The reviewer, you have 2 minutes to prepare.
And this is the problem statement. I think you have already seen it before. Next. And the theory, they use Young's equation to describe the shape of the droplet. And they are good at contrast between theory and experiment. And they will explain the data, and they say the affection of the data and the theory. There might be some, and they are good time management. But it's hard to understand the data graph. It's almost stick together, and there are lack of explanation of the theory. And as for the opponent, I think there will explanation of the problem, and they have made the problem right. They use the time very well, but they use too much word in experiment. I think that you should divide the question into several little questions, and so the reporter can know the problems well, and a little bit aggressive, I think, and discussion of the topic. First, the opponent asked, do you consider the temperature? And the reporter replied that, yes, all the temperatures are all the same in our experiment. And about the humidity, they say you use a box to control the humidity. And opponents, and why do you measure the humidity? And the opponent asked, why did you consider the wavelength of light? And they just say it is not the point of our experiment because they are doing other things. And about my question, I asked, do you think the gravitation will affect the shape of the droplet? And the opponent answered, they actually affect the surface tension, cause the curvature change. As for the reporter, they say we didn't consider the gravity because they use the Young equation, and that formula consider that all the curvature are all the same. And the next question is, do you think the curvature of the droplet are all the same in the different place of the droplet? And the opponent replied, they will be different. But the repeater also replied, no, that will be different. I take every spot curvature. They take every spot, the curvature of every spot, and take the average. And as for the next question, I asked how the wavelength of light affect the phenomenon. And the opponent replied that the minimum of the resolution will change. And the reporter just said, I think it will affect. Thanks.
Okay, thank you. So now it's time for the reporter to give the concluding remarks.
Thanks for the reviewer and opponents. Thanks for you for advice. For the short question part, we think if we change the light source, like using different color light source, because it will turn around that. So we think that will affect the angular resolution. If we put the Young equation on the PowerPoint that we just want to explain in what consider the droplet can remain a same stress that is when the surface tension is different, selection gets the balance and the water droplet will not expand. And from the reviewer question, he asked about the gravity channel. I think the weighting on the glass might be important than the gravitational. And yeah. And we think opponent didn't focus on my presentation. He just asked me about the intensity and the color of the lights, and I didn't do the explain in my PowerPoint, so I cannot sure to answer it. And the thickness of the graph, we can use the optical metric theoretical line to predict the trend of the magnification. And in my presentation, first I will use the Young equation to solve the droplet look like the droplet, and then we successfully use the optical metric to draw a theoretical line on the magnification, and it related to the object distance, the thickness of the glass, the thickness of the water, and the curvature radius. And after that, we found out that when the object distance increased, the magnification will also increase. And that's all. Thank you.
Okay, thank you. So now it's time for our jury to ask questions. So the three presenters, please come to the stage. Any question from our jury? Professor Tai.
Okay. about the definition of resolution. What the reporter used is according to the diffraction limit.
The diffraction limit.
Right. Diffraction. Light will spread out and interfere, and then that's called diffraction.
Yeah.
It will affect image.
Yeah.
But if you use your eyes, sometimes we don't use that criteria, right? Because if they're too close, it's not because of diffraction. It's because our resolving power of our eyes are limited. My question is that you use a camera, so the resolution, whatever you define it, will be affected by the camera's resolution limit. If it's a very bad camera, it probably won't do the work. So, what camera do you use? Should it be mentioned? What camera do you use?
We use axial camera.
Yeah. What's its specification?
The specification?
Yeah.
I can tell you how I
In regard to resolution.
I can tell you how I calculate camera.
Okay. It's okay. It's okay.
So, any other question?
I have a question for the opponent. At one point, you mentioned that the light intensity is related to the wavelength of the light. What exactly do you mean by that?
I believe that light intensity is inversely proportional to the wavelengths.
Okay, that's okay.
Any other question? So one question to the opponent. You mentioned about the humidity and the temperature. So why do you think it will change the result?
As the humidity and temperature change, the coefficient of surface tension between the faces will change. Therefore, the shape of the droplet will change. And as the shape of the droplet changes, the curvature might affect the magnification.
Maybe Young's equation is used to determine the contact angle. Isn't that its main purpose? It only determines the contact angle where the three faces are in contact. The curvature will be dependent on other factors such as gravity and depth. Is it correct, my statement?
You mean the gravity?
The curvature is not completely determined by Young's equation.
Yes. We also need to consider the.
So is this a good way to determine the curvature of your drop? Have you any other thoughts about how to improve it? This is just difficult problem. Determine the curvature from Young's equation.
Actually, we didn't find a solution.
I don't understand. Curvature is
I know how to use I use the Young's Laplace equation, and which is there is a delta H, which means the average curvature, and we made the formula to describe our droplet, and it is proportional to the delta P, which means the pressure difference, and the refraction rate.
okay.
Okay. So that's all. So jury, please prepare your scores. Victoria, are you ready? Okay. So firstly, the score for the reporter. 6, 6, 5, 5, 6. Okay, thank you. So secondly, the score for the opponent. 5, 6, 5, 4, 6. Okay. Finally, the score for the reviewer. 5, 6, 8, 5, 7. So, so the jury would like to give some comment about, for example, Professor Huang gives a very high score.
Okay.
To review.
Yeah, actually for the reporter and owner, I think also ranking has been the main point of this problem. That's the phased file and also phased transformation. Actually, I think your theory and the equation didn't match very well. And also their model is not, I cannot say, it's not fixed detail, it's not that well, Yeah, and then also I see your data seems did not match your curve very well also. Yeah, and also for the opponent, actually I have no idea what's the relationship between the intensity and wavelength. Actually, I have no idea. So, and
You
you
have
also,
ideas, but it's different from this.
yeah. So, and I think it's not the main point in this question. But for the opponent, for the viewer, why I give them the high score? Because they just summarize their question in their also their discussion. Yeah. So I think they already correct all of them. Yeah, so that's why I give it a high score. Yeah. Okay. That's all.
Okay, thank you. So let's stop here, take a short break, 10 minutes break, okay?